Oh, that.
Yeah.
Oh, that's weird.
Like, link to class.
It said link, and then
no
there was no.
Oh, that was weird. Okay, let's make sure real quick. Ring is on the right side. Okay, ladies and gentlemen, we're going to talk about properties and limits today. You can kind of tell just by looking at that. And again, remember, some people got extensive limits, some people got very little limits. But by the end of today, we need to be able to tell where the limit exists for a problem like this and where the limit does not exist for a problem like that. Sound?
No.
Give it a second.
I should just play it echo just
If there's nothing on the screen, exit out of it and try to go back in. Sometimes when you start the event beforehand, that does not work, but that's going to be bad news bears for me if that's not working. And anybody who's not here today. Did it work then? Yeah, that's usually the key. If you start before me, sometimes it does that. So, all right, ladies and gentlemen, today we're going to finish 1.1, properties of our friend the limit. All right, I told you the delta epsilon definition. You go to college, you tell them that's the definition, they're going to nod to you like, yeah, that's the definition of a limit. That's what a limit is. We want to be infinitely close. You tell us how close. I tell us how close we have to get to the x value that we're interested in. But there are some other properties of the limits too. Limits have two sides. Oh, to those of you that are watching this because you were in the class last year, I texted you directions on how to get off this. You just actually have to do what I said to do. You can't just say, Beckman, please get me off this. You have to reply stop. If you reply stop, it gets you off. If you reply anything else, it doesn't. No, not people that were in the class last year. Like, I told them how to get off the list this summer after the AP scores came out. Because after the AP scores, I texted out because it was really good. Our mode score was 5 again this year, which is awesome. And now all these people are, like I said, you have to reply the word stop, not whatever you feel like it is. Just reply stop and it'll work. So stop texting me like leave. I gave you directions. You chose not to follow them. You get to suffer. I'm not fixing it for you. Sorry, all you parents of kids who were in my class last year. You have to figure this one out on your own. So limits have two sides to them. Limits have two sides, and it is very important. They have a left side and a right side. The limit, as x approaches some value a that's in the domain from the right-hand side. Why do we denote right-hand side? We have to put that little plus sign because we're like coming from the right, coming from the positive of f of x. This is denoted as our right-hand limit. These are especially useful for piecewise functions when there is one rule for when x is equal to some values, and there's another rule for when x is equal to some other values. How do we note we only want the right hand? We put the plus sign. Well, what do you think we do for the left hand? We change that to a what? Yeah, the limit as x approaches a from the left-hand side of f of x is our left-hand limit. Do limits always exist? No, they don't. If you're not getting infinitely close to something, and that can happen in a lot of different ways. We're oscillating, like sine doesn't get close to anything as x goes to infinity. We don't, it's growing to infinity or going to negative infinity. There's a lot of reasons why the limit does not exist, but for the limit to exist, it has to get infinitely close to some finite value. Infinity is not a finite value. Okay, so now we get to the limit existence theorem. Oh, no, let's do an example real quick. Example number 1. I got to remember, some of you didn't really cover the limit for more than 8 seconds last year. So let's take a look at this really fun graph right here. And let's look at that. And let's look at that. Close that. Let's look at that. And let's say that this right here is 1, and this right here is -1. Yep, just say up. I used to be able to project it both ways, but this new projector doesn't have enough power for that. So, all right, so let's take a look real quick. Part A, what's the limit as x approaches 0 of f of x? Do you get them all graded?
Yep.
God, you're a good TA. Thank you very much. Caleb, don't disrupt my class. Actually, would Breebach allow that? Exactly. Then don't do it in my class either. Okay, real quick. What's the limit as x approaches 0? Well, what are we getting infinitely close to? As we come from the left-hand side, we're getting infinitely close to what? And as we come to the right-hand side, we're getting infinitely close to? Right. So we're getting infinitely close to anything. No, we're not. Now, is there a left-hand limit? So what is this? This does not exist. In fact, you'll remember from last year, if you're in Calc AP, in the AP Calc, there's a limit existence theorem that 3 things have to happen for the limit to exist. Okay, now let's look at the other one. Okay, what's the limit as x approaches 0 from the left-hand side? What's the limit, part C, what's the limit as x approaches 0 from the right-hand side? And real quick, if you're in AP last year, think of the 3 conditions that have to exist for the limit to exist at a point. If you were in IB last year, this is the first time you're seeing it. You know, we're merging 2 groups into one. Oh, no. Let's make this even worse. Question to you. That dot right there. That dot right there. I better point at it since it's on the internet. That dot right there. What impact does that have on the limit? Talk to the person sitting next to you. What does that dot have to do with the limit? Volunteer. What's this dot got to do with the limit? Ariana, you already talked to somebody else. What's the dot? Alexa. Is that? Nothing. In fact, if that dot was not even there, would our limit answers change? No. So the limit is about as you get towards a point or close to a point, not anything to do with it happens at the point. In fact, it doesn't even matter if anything happens at the point. That's continuity. That'll come up later. Whether f of a exists or does not exist has no effect on if the limit exists or not. None. Okay, so real quick, volunteer. What's the limit as we come from the left? -1? No, it's not. +1, right? Because as you come from the left-hand side, which is a little bit less than that value, which is why it's got the negative. As you come from the left, it's going towards +1. As you go to the right, it's going towards, because we come to the right, a little bit positive, a little bit bigger values than that, it's going to -1. Now question, part D, what is, in fact, f of 0 equal to? Right, f of 0. What would you get if you plug 0 into the function? You'd get the closeout, which is 0. Now you'll notice that has nothing to do with either one of the limits. Nothing to do with it. The limit is towards, it is not to. As we get infinitely close, it makes no difference if, in fact, it ever actually gets there or not. Why is that interesting? Because we're going to talk about what happens as they get infinitely close to each other, what happens to the slope of the line. What's that? Sometimes. Sometimes. Sometimes it gets shallower, sometimes it doesn't even exist. Isn't that crazy? Like you talk in math, it doesn't even exist. Imagine you put that in Algebra 1, like the answer does not exist. They'd be like, pre-algebra it is for you. Calculus, correct all the time. Stop and check out questions on that. It is. I mean, Mean Girls, what was the answer to one or the math competition? The limit does not exist, of course. We'll even show that one day in class. That's significant to your math life. All right, so we get to the limit. Existence theorem. Theorem. And Riley, can you stop talking, please? Thank you. Yes, Ayana.
Why is the entire screen flipped except for your right?
Okay, this is really odd, but they got me a new projector. Then when the new projector doesn't figure out that this thing is flipped, so you know how your camera is like naturally flipped? Yeah, it doesn't figure this out. So I had to figure out how can, because some of you I had back when I had a different dot camera that worked perfectly for this. Then I got the new one. I couldn't figure out how to make it work with this. So I had to program a setting into the projector where I just hit this button and it flips it. So all of this is coming off of the dot camera. Everything else is just on the screen, and that took me a while until I figured out how to do that. So yeah, everything else is flipped except that. Why? Because it does the projector doesn't understand that this is being flipped already. Most projectors will just automatically detect that and flip it on the ad. It doesn't. So bad news bears. But you can totally see everything on the screen with the lights on. You know, a lot of the projectors, like you have to shut the lights off to read what's on there, and I'll take that over flipping it.
We should do the next lesson with everything flipped backwards.
We should.
Just totally confused.
Imagine the parent emails.
True.
So Beckman, the screen is flipped the whole time. How do you expect my student to learn? P.S. Everybody's parents. Okay, the Snapchat. Oh yeah, yeah, okay. Okay, part A. The limit of existence. The limit as x approaches some value a of f of x is equal to L if and only if these 3 conditions apply. And you'll notice I give you a lot of conditions in the class because why? We have to fit these to rigorous definitions. Why? So when you take your AP test, you're talking the same language as the grader. The limit of f of x as x approaches a is exists and is equal to L if and only if. Part A, the limit as x approaches a from the right of f of x. and the limit as x approaches a from the left of f of x exist. Now you may say, wait a minute, what's that mean? Okay, one of them can't be going to infinity or negative infinity or be undefined. Like imagine this crazy function that's like oscillating as x gets close to 0 from the left and then like a straight line from the right. Yeah, the limit would not exist because it's not getting close to anything from the left. If the limit from the left is going to infinity and the limit from the right is going to infinity, the limit does not exist because it's not getting arbitrarily close to anything. So first off, the left and the right hand limit have to exist. Part B, they probably also have to be what? Equal to each other, right? The limit from the right of f of x is equal to the limit from the left of f of x. Now notice, I could sloppily write less than that, but this is a very precise language. And notice I am writing out the limit as it's defined every single time. If you're on an AP test and you have to find the limit and the limit's equal to 7, don't you dare put 7 and put a box next to it. That's wrong. A lot of you got your world rocked on the AB practice test last year when you're like, wait a minute, I got 7, but why am I getting no credit? That's because you didn't write it in the correct notation and you're speaking math, not 7. So if the limit's equal to 7, you better say the limit as x approaches 2 of f of x is equal to 7. So the limits have to exist, they have to be equal to each other. In other words, as you come from the left and the right, you have to be getting arbitrarily close to the same place. Do I talk fast? Absolutely. Why? Because I'm excited. I like math. If I need to slow down, let me know. I'm not offended at all. One time I was on the phone with somebody when I was an actuary and somebody told me I talked really fast, and I do. I didn't slow down for that person though, but I'll slow down for you. Cameron.
You ever measured your lung capacity?
No. I was a drummer in high school. Nobody cared if I had lung capacity or not. They didn't care if I had brain capacity either. Well, if I was a trumpet, they'd care if I had both brain and lung capacity. But drummers, you know, you just replace one of those with the next person that walks through the door. So, besides Arjun and Maggie, anybody a drummer in here? Yeah, don't worry, Maggie. My director would always make fun of me that I can replace you with whatever TA comes through with the next pass. So they'd be equally as good too. So, yeah,
You just said that.
I just said that.
Oh, okay.
When I said Arjun, I was talking about Arjun.
I guess that's what happens when you drop the bait.
I know, you start dropping the bait and suddenly you can't hear anybody talking anymore. Good job. Kiwi, you want to try debate?
I would if I had time.
And part C, L must be unique. Now you may say, oh, Beckman, you just could have said, oh, they're going to the same place. Yeah, rigorous definitions. This isn't going out. This is math class. We give rigorous definitions when we want to define things in here so everybody knows what we're talking about. Going out, nobody's ever going to know what that meant. L must be unique. In other words, you can't have two different limits. Why? I think Ariana or Riley, one of you got that. If it's not, then it's not a function. And calculus is a study of functions for the large part. Life is a study of functions for the large part. All right, stop and check up on questions on that. Questions on that. All right, copy this down. Copy this down. You ready, set, go.
Yes.
Sure. Okay. The parents keep texting. Please remove. I sent you directions on how to do this. You ignored them. A, B, C, D. Do we know about anything? Okay, question. A is going to be what? Positive or negative value? Negative. Yeah, that's all we know about A is it's negative. And in fact, it's to the left of B. Yeah, it's more negative than B. How much more negative? We have no idea. It could be 0.01, it could be a lot. C is positive, D is more positive. That's all we know. Okay, now you're really smart. What kind of questions do you think I'm going to ask you? Yeah, limit questions. In fact, where am I probably going to ask you the left and right hand limit questions? Oh, A, B, yeah, B is a good one. C is a really good one. D's, yeah, boring. Everybody gets D right. Okay, here's my question to you. A, B, C, D, where does the limit exist? A, B, C, D, where does the limit exist? Talk to the person sitting next to you. A, B, C, D, where does the limit exist? At which points, A, B, C, D, does the limit exist? Now you may say, oh, that's a weird question. Bam, old AP question. You're going to do AP questions all year. I know a lot of you complain about not having them. You're going to get them all year in this class, so be used to it. Where does the limit exist? A, B, C, D.
D does. A does. Oh, what about C? C does. No, D doesn't. C does. C does.
A, B, C, D. Where does the limit exist? All right, volunteer. Volunteer. Who wants to volunteer the person sitting next to them? So somebody wants to volunteer. Josh. Where does the limit exist? A, B, C, or D? D? Okay, let's talk about D real quick. The limit exists if three things happen. Number one, the left and the right hand limit have to be what? No. First thing, they have to exist. In other words, is the left hand limit equal to a finite number? Yes. Is the right hand limit equal to a finite number? Do we really know what that number is? Nah, it's somewhere between 0 and -1. Does it really matter? No, I'd ask you if the limit exists. So the left and the right hand limit exist. Good. They also have to be what? Equal to each other. And there has to be only one limit. So again, I'm giving you checklists, just like I give pilots, just like they give your parents when they're doing important things in life. Make sure you do this and this and this. When you need to say, does the limit exist? Hopefully last year they gave you the checklist. The left and the right hand limit have to exist. They have to be equal to each other, and it must be unique. They have two limits. Okay, Sean, so D is an easy one. The limit exists. Okay, what about A? You said A too, correct? Okay, why do you think the limit exists at A? They exist. They go to the same spot and unique. Okay, now I realize most of y'all took calc last year. What doesn't happen at A? What doesn't exist today? The derivative doesn't exist today. Why doesn't it exist today, real quick? Yeah, because what is your slope of your tangent line is going to be right here? Well, no. What are your slopes of your tangent line is going to be here? I can't tell you the number, but I can tell you they're what? Positive. And then here, they're negative. Okay, what's wrong with that? Like y equals x squared, it goes from positive to negative. It exists at y equals x squared. At x equals 0, it goes from negative to positive. Why does that one exist and this not? What's that? Concave up. Okay, what's concave got to do with it?
The slope has to be increasing, so it can be increasing and then flip to negative.
Okay, question. What's happening to the slopes? Concave up's got something to do with it. What's happening to the slopes as they get closer to A?
They're
It's
increasing.
getting steeper. So in other words, the value of the slope is getting bigger, more positive, right? And then what happens here is it gets smaller. In fact, they're going towards what? The infinity. Right here, they're going towards infinity. If you graphed it, it would look like this. Why does that not lead to a derivative there, though? What happens at that point? You instantaneously switch from what? Positive to negative, right? And not only negative, positive. Really fast positive to instantaneously switching to really fast negative. Do our laws of physics allow us to do that? No. No, if you could, man, you'd get out of every speeding ticket on the planet. Do that. Also, I instantaneously switched from when I was going increasingly positive, I instantaneously switched to going instantaneously negative. You don't get this. Not only was I not speeding, I was going negative 700 miles an hour. Like, you owe me a treat.
Supersonic.
Yeah. That's why the derivative doesn't exist at that point. Comprende? And I assumed you talked about that last year anyway, so that's all.
Well, we learned
Not-
because it's a cusp.
Yeah, that's all we learned. Because
That's all. That's what.
That's why I did it with my thesis.
A cusp?
Yes.
That's
With
why.
no explanation. They just
No,
like, what's the cusp?
It's a cusp.
It's a cusp.
So there's no derivative.
I heard something about
Oh, yeah, it's like
that
concave.
tangent line
We
being
didn't.
what we defined.
We didn't hear that.
Well,
We did.
here's the reason why. It's because as you go from the left, the tangent lines are increasingly positive, and as you go from the left or from the right, they're increasingly negative, and you can't switch from positive speed to negative speed instantaneously. That violates the laws of physics. Plus, it doesn't make any sense. And that's why the cusp doesn't happen. Now, as you can probably tell, am I a big fan of just telling you to memorize stuff and then saying, go get them, Tiger? Absolutely not. You need to understand this calculus. It's how you're going to remember it. It's how you're going to make a lot of money off of it. Because I guarantee if you walk into work the first day, you're like, because it's a cusp. And they're like, well, why does the cusp have a derivative?
Because it's a cusp.
And then if you can explain, well, it's because you're changing lines as you go from the left, you're going to infinity, and from the right, they're going to negative infinity, they're going to be like, you are hired. In fact, you're promoted. The person who interviewed you, you're now their boss. So go get them, Tiger. Questions on that? Do you realize you're going to walk out of this class pretty smart?
Yeah.
Yeah, you should. Wait till the crazy stuff at the end of the year. You can't even read it right now. Okay, why does the B and C, why does the limit exist at B? Napor, why does the limit not exist at B? You're not Napor. You're Stefan. The limit exists at Stefan. No. Napor, why does the limit not exist at B?
Because, I'm sorry, I don't
Well, what are we getting close to as we go to the left of b? We're getting close to, as we get close to b from the left, the function is going towards what? You know, okay, I said that's negative what? Yeah, negative 1. So that's positive 1, that's negative 1. As we go to the right, Nipur, where is it getting close to? It's getting close to 0, right. Are those the same numbers? No, limit doesn't exist. They have to be going to the same place. You can't instantaneously switch from, just like you can't with the speed, you can't instantaneously switch from negative 1 to 0. The limit doesn't exist. Limit from the right is going to 0. Limit from the left is going to negative 1. Those are the same numbers. Those are the same numbers. Limit doesn't exist. Another volunteer. Another volunteer. Actually, I like to call you victims because I'm. What's that?
I volunteer Kyle.
Volunteer Kyle. Kyle. That was nice. Kyle, C, why does the limit not exist?
Because if you're going from the left to the right, you're to infinity.
And we don't even care because the limit doesn't what? The right-hand limit doesn't exist. That's all you need. In fact, you could have just said the left-hand limit doesn't exist. That's all you need. If the limits don't exist, there certainly can't be a limit at that point. Now, it is possible that it goes to infinity here and then like 7 here. So the right-hand limit can exist, but the left-hand limit doesn't. The limit doesn't exist. Let's stop and check out questions on that. I know a lot of you had a lot of experience with that, and some of you had no experience with that, but I am trying to make it challenging enough so everybody gets experience with it, or at least you learn something from it. That's why I kind of been asking, you know, derivative things, get that dust off your head in there, but questions on that. Now again, do I teach for memorization? Oh, math, I don't. If you want to memorize stuff, take somebody else. That ain't Beckman's cup of tea. It's unfortunately why they assigned me BC against my will. So, I missed a meeting. Walk in the next day, like, hey, you're teaching Calc 2 next year. It's like, we don't even teach Calc 2 in high school. That's hilarious. No, you're teaching Calc 2 next year. I was like, well, last time I did Calc 2 was 1999, so I better take a Calc 2 class this summer. No joke. What's that? What's a good year? Graduated high school in 99. Started dating my wife in 99. Riley was doing something else in 1999.
I don't think it's about you.
Yeah, okay. Well, no, look, PG. Nobody needs to know about that. Okay, do we need to do another example?
I got some
Sweet. Oh, cool.
Presents.
Yeah, more presents. All right. Do we need to do another example like that? Yes, no, any yeses?
You're the teacher.
I'm the teacher. Let's do another one. Part A. Well, yeah, Kiwi.
It's your choice.
Kiwi. No, it's not really my choice because if I Kiwi,
We are the customer.
you're the customer. Number one, if all y'all already got it, but I like. Hey, there we go. All right, Mike, let's go for example number 3. Let's have some fun with this one. Let's go for this.
That is confusing.
That's good. That's good. I want it to be confusing. All right, there's that. And then there's this. We'll make that 0. We'll make that 1. We'll make that 2. We'll put a dot right there. We'll do that till there. And then we'll do a little bit of this. Okay.
Something.
Oh, Luke, you just forgot what my class is like. All right, part A, here we go. Let's go for, we're online, Luke. I can't do that. There's creepers on here. But guys, you got to stop. Let's stay on focus. Let's keep going. I know some of you screwed around all last year, but yeah, there's lots of Iranian, like you'll see it too. Sometimes the Iranian people that watch these online, which I don't know why I'm so popular in Iran, but they will make comments about, well, I don't really want to know why they're watching Jeremy Beckman math videos on Calculus 1 in Iran. Like they block MIT, they block Dartmouth, but they don't block Jeremy Beckman. Yeah, watch this guy. He'll teach you calc. Okay, limit as x approaches 0 of f of x is equal to what? Part B, the limit as x approaches 1 from the right-hand side of f of x is equal to what? Part C, the limit as x approaches 1 from the left-hand side of f of x is equal to what? Part D, what's the limit as x approaches just 1 of f of x equal to? And then part E, let's go for the limit. Yeah, let's get our money's worth out of this one. The limit as x approaches 2 of f of x is equal to what? And then let's go even more fun. Part F, what is f of 2 equal to? Ooh, yay, fun ones. And Kiwi, if you haven't figured out, I make examples up based off what, I largely base my class off what I feel you guys need and where you are and that type of thing. And I can make these examples up all day long. I love making up math problems. So, in fact, those of you that try to use the method you used last year, like I'm just going to take a picture of Beckman's test from last year and use it, bad news. Sometimes I'd make up even problems like the class period before this one and change the test. So your copying machine method is not going to serve you very well here. So
F of what was this? 2.
f of 2 is equal to what? F of 2 is equal to what? Yes. You're not in prison. You can just go.
Yeah.
Okay, people, you're basically in college at this point. I'm gonna basically treat you like you're in college. Now, if you start doing dumb things that start interfering with your ability to do well in class, like you're on Instagram all period, yeah, I'll talk to you about that. But right now, you gotta go to the bathroom, you go to the bathroom, girl. In college, you just go. Don't stop the prof. He's having fun teaching. All right, part A, volunteer. Part A, volunteer. Willow, part A.
It doesn't exist.
Why not?
Because as it comes from the right, it's at -1, and it's coming from the left.
Okay, question to you guys. What about the limit as x approaches 0 from just the left of f of x? What would that be equal to? Are you getting infinitely close to 1? Yeah, you are. It's oscillating. As x goes to negative infinity, there probably wouldn't be a limit, but as x gets close to 0, there is one. A finite point there is. Okay, so part A, limit does not exist. And that's literally the words you write. Does not exist. Part B, limit as x approaches 1 from the right of f of x is equal to what? Volunteer for that one. Is this that hard?
No.
Like there's like 3 hands up. It's like the easiest problems of the whole year. Step 5.
It's 1.
Equal to 1. How do you know that?
Because as you go to the right.
Oh no, let's use the good words here. As you get.
As you get arbitrarily
There you go.
close to x equals 1
Yep.
from the right, then you get arbitrarily close to y equals 2.
Okay, and here's the kind of crazy part. In fact, it's constant there. So there, what would our delta be equal to? How close would we be? 0, right? We can make our delta equal to 0 at that point because it's constant. The distance between your limit and your function is equal to 0. Look how close that is. Don't tell your girlfriend's dad that's how you want your delta to be equal to a color dance. That's going to be trouble. You'd be like, oh, we're going to go and delta's going to be equal to 0. He's like, oh no, it's not. It's going to be a constant function all night. Absolutely not. All right, C, the limit. I know. It's hard to talk to people who haven't taken calculus in social situations after you've taken calculus. Because they're talking about like, I want to get close to you, and you're like, well, what do you want your delta to be? You want to be arbitrarily close, like 0.001, 0.001, 0.001? I know, and then they're looking at you like, we're not flying. This isn't Delta Airlines. Like, what are you talking about? You're like, we have to break up. I'm sorry. Don't take Calc 1, we can meet again. The limit as x approaches 1, and wait till diffie q. If you take diffie q, like you're being an engineer or scientist, you take diffie q and then try to date somebody who didn't take diffie q, you're out shoveling snow and you're like getting this giant divorce causing fight over it. And it's all because they don't really understand the rates of change that are going on in the universe right now, and you're like, you don't get it. Okay, part C. Limit as x approaches 1 from the left is equal to what? Volunteer. Yep, Caleb.
1.
1. So what's the limit, part D, what's the limit of x approaches 1 then of f of x? 1, right, yeah, because left right-hand limit, they exist, they equal the same thing, and there's not more than one. Okay, limit as x approaches 2 of f of x, volunteer. Limit as x approaches 2 of f of x is equal to what? Somebody who hasn't talked, McCutcheon.
Danny.
Does not exist, why not?
Because on the left it approaches 1, and on the right it approaches 2.
So it violates which part, A, B, or C of the existing theorem?
B.
Part B, right, the limits aren't equal to each other. Part F though, crazy part, what's f of 2 equal to? What's f of 2 equal to?
Is that an open dot or a closed dot?
Those are open dots, yeah, those are open dots. Yeah, it's not equal to anything, does not exist. Right, there's no closed dot. Does that affect the ability for the limit to exist? No, and if it, hold on. Especially because it's the same thing. Let's see what this one is. Yeah. I already replied stop. Yes, you did, but you put it in quotations. That's why it didn't work. I didn't say put stop in quotations. I said just reply stop. And here's the deal. Like we talk about precise languages, and I know y'all got your world rocked on the AD practice test last year because you're like, I didn't put f prime of x is equal to 7. I got the whole question wrong. Yeah, that's because nobody knew what your answer meant. Yeah, it's a really precise world we live in. All right, f of 2, there is none. Does it affect the ability of the limit to exist if f of 2 doesn't exist? It has nothing to do with it. Nothing to do with it. All right, let's talk about 2 more things. We're actually going to get a little bit further than I thought today. Let's go back and what should we do? Yeah, let's talk about secant lines and tangent lines. Secant lines and tangent lines. At the start of the year, hopefully, I think I did, but I can't remember if I did or not anymore. There are 2 problems we're going to try to solve in Calc 1. We're going to try, number 1, the tangent line problem. In other words, what is the slope of a line tangent to a curve at some point? And then number 2, what is the area under a nonlinear curve? Well, first off, we're going to talk about tangent lines. That's the first thing. It leads to this fun thing called the derivative. It's how we got it. Secant line. So let's draw a graph in here real quick. If you got 2 colors, it's probably helpful for this. So let's draw a really fun line in here. It looks like that. I don't know, some x to the 3rd function. That's not really all that fun. And really what we're interested in this point is this point right here, A. This point right here, A. And of course, when we plug in A, we get f of A. Why? Because this is f of x. Plug in A, we get some value out. What is it? F of A, what's f of x? We don't know, we don't care. Why? Because we're just talking generalities at this point. We really want to know what's the slope of the line at that point. What's the slope of the line at that point? So we hopefully last year in Calc 1, but we don't have time in Calc 2, you did some sort of investigation where you put this into your calculator and you zoomed in, and you zoomed in, and you zoomed in, and you zoomed in, and eventually your function looked like what? A straight line. Good news. No matter how nasty your function is, if there is a slope at that point, the more you zoom in, the more it looks linear. It's a linearization of a function. You zoom in and zoom in and zoom in. And what we're trying to do is find the slope at that point right there. Now, for sure, we could say that slope is what? Positive, because the function is doing what? Going up. Now, if we had that slope, we could draw in the line tangent to the curve at that point. Now, the problem is it's not a straight line at that point. It's a nonlinear function. So what are we trying to do? We're trying to find, number 1, the first question of calculus. Did I already write this down in your notes? No. Okay. I teach Calc 1, and ironically enough, they're a little bit ahead of you right now, but that's just because they didn't have to do the fun delta epsilon definition. They will later. They'll suffer. First question we answer in Calc 1. First question we answer in Calc 1. What is the slope of a line tangent to a point what is the slope of a line tangent to a point on a nonlinear curve. Now you may say, well, nonlinear. Okay, algebra 1 kids can find the slope of a linear equation. You just y2 minus y1 over x2 minus x1. Why? Because the slope's the same no matter what. Now here's the bad news of this one. Almost every point on here has a different slope. I mean, you just go a little bit to the left, slope's totally different. Might still be positive, might still be negative, but it's a totally different number. Why? Because you saw the cop, so you started slowing down. Or you saw the cop chasing you, so you stepped on the gas because you're like, I gotta smoke his butt out of the DCC parking lot. If I get close enough to, if I get arbitrarily close to Chick-fil-A, he'll get hungry, and he'll get arbitrarily close to wanting lunch, and he'll forget about me. So,
There's some you're not telling us.
what's that?
Some you're not telling us.
No, Chick-fil-A is delicious. I mean, that's a universal truth. There's a reason why the line's so gigantic.
It's arbitrarily close to getting really mad and then shooting you. The more you run, just stop.
Well,
That's
that's
political.
Let's get back.
All right. Threats on the internet, just FYI, that was not me that talked about shooting. So that's the first question we try to answer. Okay, so we say, well, how did we find the slope of the line back in the glory days of Algebra 1? We took 2 points and we found what? Right, Algebra 1, back to the glory days of Algebra 1. Algebra 1, we found the slope, which is its slope. We abbreviated with m. Why? Because that's the Latin for slope. That's the only real reason for it. But otherwise, it's really confusing. The slope is abbreviated with m. But y2 minus y1 over x2 minus x1. And at some point, your teacher really wanted to beat in your head that that was how much the y values changed over how much the x values changed. That delta, how much change do we want? Or how much tolerance is there between the two? Delta Airlines, no joke. Triangles are on the back of all their planes. Why? Because that's a Greek delta. It meant change. So they wanted to beat in your head that it's a change in y over the change in x. Now here's the cool part. For a linear system, it doesn't matter what 2 points you choose, it's always the same. For a nonlinear system, it's always different. So we start to think, well, wait a minute, how are we going to find slope? Well, what we're probably going to do is we're probably going to use this point, and we're going to use another point that's what? Really close to it. How close? Arbitrarily close. But here's the problem. We didn't know the limit yet, so we had to pick 2 points that were really close to each other. So let's draw that curve again. And here it roughly is, kind of looks the same. So there's our point A that we draw in. Well, then we found some point that was close to it. Let me use another color. Let's find this point B here. So we plug in a point B, and that gives us f of B. B f of B. And what did we want to do? We want A and B to be as close as possible. The problem is that for us to find the instantaneous rate of change, they need to be the same point. A and B need to be equal to each other. The tangent line problem says, well, we need A to be equal to B. The problem is, if A is equal to B, your x values are equal to each other. What happens to your denominator? It's equal to 0, and dividing by 0 gives us a big problem, right? It gives us a big problem because it gives us a vertical line, and we know for sure this isn't vertical motion right here. It's positive, it's going up, but it's certainly not vertical. That's the tangent line problem. How do we do that? So what do? We make them as close to possible to each other. So the first thing we're going to do is we're going to say, okay, we're going to let them be close, but there's still going to be some distance between them. Okay, so our first attempt at this, which really is in pre-calc. If you had me for pre-calc, I'm sorry, we did that. That was our first attempt at calculus. If you remember, I called them the difference quotient problems because we tried to make those distances as close to each other as we could. But we didn't know that we could take the limit yet and make them actually as close to 0 as we could and see where it was going towards. Our first attempt is we found the average rate of change. We found the average rate of change, and we made the distance between A and B really, really small. I mean, because always, on the first date, you don't want to necessarily try to hold hands right away. You just like slowly move your hands closer to each other. And eventually they get closer and closer and closer, but they never actually touch because you're too nervous because you're worried if you touch, like her dad's going to instantly apparently pull a Caleb on you. Right, so the first attempt, kind of like a first date, we try to make them as close as possible and see what's happening. So we try to make A and B as close. The problem is that's an average rate of change. In other words, there is a distance between those 2 points. That's the cop saying, uh-oh, I see you, and then I see you later, and I see, well, how far did you go, and how far was it in between? And we find the average rate of change. The problem with that is you slow down. It's over some period of time. So with that saying, that gives us an average rate of change, which we call then generating the secant line. The secant line is an average rate of change. Yay, average rate of change. And surprisingly, I'm going to teach you all this calculus stuff, and then later on, they're going to ask you to find the average rate of change. You're going to be like, what? We didn't cover that in this class. I'm going to be like, second day. Yeah, because after 90 days of class that we jam a gigantic amount of information down your throat, it's hard to remember what you covered on day 2, and that's why we do an extensive amount of review for the test. The secant line is an average rate of change. This is over 2 points. In other words, there is distance between these two. It's 2 unique points. What we're going to do eventually is we're going to find the instantaneous rate of change by making those points be 1 point. In other words, the distance between those two, we're going to make it as close to 0 as possible. In fact, we're actually going to find a way that's actually equal to 0 too. Why? Because we're going to do this unbelievable limiting thing. Hold on just a second. One of my colleagues is going to Chick-fil-A, and I'm going to choose Chick-fil-A over ham sandwiches 100 times out of 100. So I didn't get this skinny by eating good. So well, I did actually by eating good. It just wasn't healthy. So okay, it is over 2 points. In other words, there is going to be some distance in between. That's how we started. Then we say, then we're going to take the limit to be able to do it. So here we go. So let's take a look at this function. And how would we find it for this particular function, for this example? Example. To find the slope, we would take f of b minus f of a over b minus a. That doesn't give us an instantaneous rate of change. It just gives us an average rate of change. It gives us a secant line. In other words, the slope of the line between 2 points. Okay, so let's take a look at a very nice and easy function, a very friendly friend. Let's take a look at y is equal to, example, and this is example 3 or 2? 4. Look at me giving you money's worth. Okay, let's take a look at an old friend. Let's look at y equals just our friend x squared. Nah, let's go x squared plus 7. That's too easy. TCA kids can do that one. X squared plus 7, we got them. Oh, believe me, any TCA kid that watches this knows my personal feelings about TCA. Did one of you go to TCA at one point? No? Okay, good. What's that? Good. Well, some kids, they get kicked out of TCA because they're only got an 87% in reading, and then they have to come to DCC and make all new friends, and that's the saddest thing ever. So seriously, it is. You know how y'all write your math autobiographies? The only ones that actually made me cry here at DCC is this girl I had her freshman year. She's a TCA all kindergarten through 8th grade. They kicked her out for not doing well enough in school. And she's talking about, I don't know anybody at the school. I hate everybody at the school because they all hate TCA kids. And I have no friends that go to school here. And I'm freaking crying. They kicked her out because she wasn't doing well enough. It's a public school. Could you imagine if I was okay, you only got an 87% in calc. My goal of this class was we're going to get 4s or 5s. And you're not going to get one. So now you're in business finance. It's next door. You'd be he's the most heartless jerk ever, but they do that as a school. That's horrible. That's against public education. So anyways, I love TCA. They're my BFFs. They're my favorite school that's not as good as us. So y is equal to x squared plus 7. Okay, so let's find the secant line. Let's find the average rate of change. Okay, so we want to find the secant line slope and equation, which is going to bring back the glory days of Algebra 1, between let's go 0 and 2. Now, is that a very good approximation? No, 0 and 2 are 2 away from each other. 0 and 0.02 are fairly close to each other. So this isn't going to be an unbelievable approximation of what's going on at 0, but it's better than 0 to 3 or 0 to 4. So of course, one of the things I want you to understand is the closer those 2 points get to each other, the better the approximation it is at that point. The closer those two get to each other, the better it is at that point. 0 to 2, not very good. 0 to 0.00001, pretty darn accurate. You can make it better though. That's involving the limit. So what do we need? Okay, we need f of 0 and f of 2. On your own, ready, set, math. What's f of 0 and f of 2? Ready, set, math. F of 0, f of 2. Ready, set, math. f of 0, f of 2. 402, 402, 402, 402, 402. Just a second. I gotta have somebody go grab something. 402, 402, 402, 402, 403,
4010. Live?
Do you have one of your pieces? Yeah. Brett. Brett. Like tangent. Really qualified to have that.
All right, what's f of 0 equal to? 7. What's f of 2 equal to? 11. Right. Okay, so there's some growth. So how do we find the slope? 7, 11. Okay, yep, so how do we find the slope? Our glory days, we take f of 2 minus f of 0. Thank you. 402. Okay.
403.
What am I thinking right now?
Yeah.
Okay, now look really smart. What's 11 minus 7? What's 2 minus 0? 2. All right, so what's the slope there? Now here's the bad news, though. If we want the, what should we say here? If we want the equation for, so now we got the slope. We know between 0 and 2, the average rate of change is 2. Between 0 and 2, the average rate of change is 2. Okay, great. You know, 2 miles an hour, 2 dogs per year, $2 per kitten. I don't know, whatever rate you're talking about. But if we want the equation for the line secant to f of 2, well, we need y equals mx plus b. No, you do not want that. No, no, no. Never, ever again. Yes. And now notice you're crossing it out. In fact, you're finding the reddest marker you have and deleting that. Never. Y equals mx plus b is a day that has gone from you. Sort of like degrees. We had fun with those in middle school. We had fun with those in geometry. And now our math has advanced past this. When you need to find the equation for a line, y minus y1 is equal to slope times x minus x1. Now you may say to yourself, what is x1 and y1? x1, y1 is the point we want secant, or later on tangent, to. No, no, no. Our days of y equals mx plus b are gone. The only possibility of me ever letting you ever use that once is if they happen to give you the y-intercept. That's it. Any other situation, don't you dare do that. Because what's the enemy of you wanting to go to college you want to go to?
MX plus B.
Time, right. You haven't got time on the ACT, you haven't got time on the SAT. Don't mess around with trying to find B. You don't need to know B. You know a point, just do that and distribute. Number 2, on the AP test, they will take any version of the line that you have. Any version of the line you have, y equals mx plus b, y minus y1. There's one I'll introduce when we talk about the derivatives. Y equals mx plus b, you don't have time to find that. Just plug in a point and you got the answer. So here we go. Okay, well, wait a minute. What's the point we're interested in here? 2 comma what?
Squat.
What? Oh, secant. Yeah, that does kind of look squat. Secant. That doesn't look much better though.
I'll write it back.
All right. Yes, Caleb, do your squats. Okay, so what's the point we want to be secant to? 2. All right. So okay, wait a minute. 2 comma what? 211. Right. That's where we want to be secant to, later tangent to. Secant to is 211. Okay, that's great. So we have y minus the y value. What's the y value of that puppy? 11 is equal to our slope, which is 2. Slope times x minus our x value. What's the x value? 2. Now here's the deal. If they ask you for an equation of the line, they will accept any form of the line. Standard form, slope-intercept form, point-slope form. This puppy is called point-slope. Later on, I will introduce you to a little different version of this. All I'm going to do is add y1 to both sides. Trivial. That's the derivative form of it, but that is point-slope form. It is the quickest way to find any equation of a line, and it's your go-to in this class because you need the time. You need the time. Now, can you solve this for m? Yeah, what do? You distribute and you add 11 to both sides. Then you got y equals mx plus b. I think this is even faster to find y equals mx plus b to start with point slope form. If you had me for algebra 2, like I spent a day just trying to convince you of that. And then I told you, someday some jerk's going to teach you calculus and be like, yeah, you need to forget about y equals mx plus b and use y minus y1 is equal to m times x minus x1. This is that day. Caleb.
After teaching me that, I realized how much time that I wasted solving for B.
Yeah, and really, and here's the deal. I don't really know what the point of that is in algebra 1. Like, why do we make you do that? This is so much easier. So much easier. So anyways, continuing on. Questions on that? Okay, what's this look like real quick? Because some of us like to see, like, what would this look like? Yay, what would this look like? Well, as soon as you use the words look like, that means we're going to take out our what? Graphing calculator. Whip out your calculator. If you haven't got one yet, parent night tomorrow night, I'll basically spend all 5 minutes I get with your parents convincing you to buy a CXCAS. Now, bad news, if you do have a CXCAS, I'm not yet teaching to that in this class. I'm going to spend about the next 3 weeks teaching with this one, and then I will tell you I'm going to switch next week. If you have the CXCAS, when you ask the question, how do I? Oh, what? Okay, graph this. I'll text out your homework. Have a good night. If you need to know how to do something on the CXCAS, hit the menu button. Where is it? It's in the menu button. It's like Windows. Everything's on the Windows button. It's on the menu button on the CXCAS. Darn it, I thought I had 5 more minutes.
Are these
left.
like hours?
What's that? Yes, take them home. Those books, take them home. At some point, I will say bring those back because we won't do. What's that? Oh, yeah, that's yours. Girl, you paid for it. Remember, there's a class fee